Fusion Mobile, quality e-learning experience on the go.
Good day, you're welcome to Fusion Mobile e-learning class. My name is Bolaji. I'm here to speak on the subject mathematics, and the topic before us today is geometric progressions. The acronym of geometric progression is GP. Earlier on, we've discussed about AP, arithmetic progressions. We chose the sum of arithmetic progressions. We chose the n term of an arithmetic progression. But today we're going to show the n term of a geometric progressions and the sum of a geometric progressions. Look at the first term. We are going to consider the first term. Geometric means sum of geometric progression and sum of infinite series of geometric progressions. Now, what is the meaning of first term of a GP? The meaning of first term of GP, that is what we are going to see. Geometric progression. A denotes first term in geometric progressions. A denotes first term in geometric progressions, which is equal to the first term. We also have A, which is being denoted as first term in arithmetic progression. We have what is called common ratio in geometric progression. We have R, which is quoted as common ratio in geometric progression, which is denoted with R. Now, we are still going to move on with what is called n term. There's n term in arithmetic progression and there's n term in geometric progression. The n term is denoted as Tn equal to a raised to power n minus 1. Tn a raised to power n minus 1. This is the n term in arithmetic, in geometric progression. Our R, I've told you, is common ratio. Our A is the first term, and our Tn is the n term in geometric progression. There's formula for sum of geometric progression, which is this. The formula for sum of geometric progression, is denoted with Sn. Sum is denoted with Sn, which has a formula of A bracket. That's the first thing you have to write. R raised to power n minus 1 over R minus 1. This is conditional. How did I say it's conditional? If our common ratio is greater than 1, that is, if our R is greater than 1, we use this formula. If our R is less than 1, then we use Sn is equal to A bracket into R raised to power n, that is 1 minus A raised to power, that is R raised to power n over 1 minus R, if 1 is greater than the common ratio. So two formulas are being given to find the sum of a geometric progression. One, if the first time is greater than 1, if the common ratio is greater than 1, we use A bracket into R raised to power n minus 1 over R minus 1. If the 1 is greater than the common ratio, then we use A bracket into 1 minus R raised to power n over 1 minus R. So this is the formula for sum of a GP. Why the sum of AP, we remember that the sum of AP is Sn equal to A plus, that is n over 2 plus A bracket into n minus 1, then bracket D. That's the sum in AP. But the sum in GP is equal to A bracket into R raised to power n minus 1 over R minus 1, if R is greater than 1. But if R is less than 1, the answer is equal to A bracket into 1 minus R raised to power n over 1 minus R. That's the sum in GP. I would like us to consider this example so as to know the differences between the sum of AP and sum of GP. Let's consider this example. Example 1. The third term of a GP is 63. Third term of a GP is 63. The third term of a GP is 63. Why its fifth term is 567? Why the fifth term of a GP is what? 567. The question is, what's the sum of its first 7 term? The third term of a GP is 63. Why its fifth term of the same GP is 567? What is the sum of the first 7 terms? Now, look at my hand. Solution. I want you to fasten your eyes to this board very well because you're going to have the full details. T3 is equal to, what is our first term? We don't know. What is our common ratio? We don't know. But we know that the n term of this one is 63. Therefore, our T3 is equal to a raised to power r n minus 1, a raised to power r n minus 1, which is the formula we're going to use, that is Tn equal to a raised to power r, a r raised to power n minus 1. Tn is equal to, what is our first term? We don't know, that is a. What is our common ratio? We don't know, r. What is the third time? 3 minus 1 is equal to what? 63. Equation 1. Because they said why its fifth time is 567. The second one is Cn equal to a raised to power fifth time 5 minus 1 equal to what? 567 is equal to equation 2. So GP leads to simultaneous equation. This question is giving us a clue on what is going to happen. If the first third term of the same GP is 63, while its fifth term is 567, how do we find our first time? How do we find our common ratio? Then equation 2 divided by equation 1. That is how we can find our answer. Equation 2 divided by equation 1. But before then, look at this equation 1. Tn is equal to a raised to power 3 minus 1, which is 3 raised to Tn is equal to a raised to power 3 minus 1, which is equal to Tn equal to a raised to power 2 equal to 63, equation 1. Also look at here, a raised to power r raised Tn equal to a raised to Tn equal to a r raised to power 5 minus 1, which is 4, equal to 567, equation 2. Now we've gotten our equation to be this. Let us proceed by looking at how we can solve it simultaneously by finding the first term and the common ratio. By finding the first term and the common ratio. Look at the equation on the board so that we can get it. Equal to a raised to power r, a r raised to power 2 equal to 63. While a raised to power 4 equal to 567. Equation 1, equation 2. How do we solve it? As I said, the thing that we're going to do, the next step is divide equation 2 divided by equation 1 to find our r. Now, this is equation 1, this is equation 2. A r raised to power 2 over a r raised to power 4. This one is equal to, what is our equation 2? 5. Okay. AR raised to power 4 over AR raised to power 2, 567 over 63. A cancel A here. Now, according to law of indices, where you have the same base, it's going to turn to R raised to power 4 minus 2 equal to 567 divided by 63 will give us what? 9. So R raised to power 4, because of this division, it will turn to minus according to the law of indices when we are solving application of indices. R raised to power 4 minus 2 will give us R raised to power 2 equal to what? 9. How do you find our common ratio when you have R square equal to 9? R is equal to root of 9, which will give us what? 3. So our common ratio is 3, which means the sum of the GP that I gave you the formula earlier on, which is Sn equal to A bracket into R raised to power n minus 1 over R minus 1, because of the fact that the common ratio is greater than 1. So that formula make it more effective for us to be used. Now, how do we now find our first term? We have to find our fourth term by using any of the equations. You can use equation 1, you can use equation 2 to find our first term. To find our first term, let us use equation 1. Use equation 1 to find the first term. Use equation 1. Use equation 1 to find A. Knowing fully well that our R is equal to 3. Equation 1. A, then substitute your R, that is 3 raised to power 2, equal to 63. Now, 3 raised to power 2 is equal to 9. We have 9A equal to what? 63. Divide both sides by what? 9. 9A over 9 equal to 63 over 9. 9 here 1, 9 here 1. 9 here 1, 9 here equal to what? 7. Our A is equal to 7. While our R is equal to what? Equal to 3. So the first term is 7, while the common ratio is 3. Now, the next question that it has us to find is that find the sum of its first 7th term. The first 7th term. Remember, our formula is Sn is equal to A bracket into R raised to power n minus 1 over R minus 1. Because our common ratio, which is 3, is greater than 1, makes this formula to be more effective. Now, our n is equal to what? 7. That was the question they asked us to find. This is the formula for the sum of the GP, geometric progression. Therefore, our sum is equal to A. What is our A in this place where we find this 7? 7 bracket into, what is our R? Our R is 3. And this 7, which is what? 7 minus 1 over, what is our common ratio, which is 3 minus 1. So this formula has satisfied the equation for us to find the first 7 term. The first 7 term. Therefore, we have Sn is equal to 7 bracket into 3 raised to power 7 minus 1 over 2. 3 raised to power 7 minus 1, which will give us, check your calculator, 3 raised to power 7 is going to give us 2187. That is 7 bracket into 2187. 2187 minus 1 over what? 2. Sn equal to 7 bracket into 2187 minus 1 will give us 2186 over what? 2. 2186 over 2. Therefore, we now have, that is, you use 7 to open this bracket and divide it by 2. 7 times 2186, which will give us 1000. That is, 7 times 2186 will give us 15,302 divided by 2. And the answer to it is what? 7651. 7651. The answer is 7651. Therefore, the sum of this geometric progression for the first 7 term, the sum is equal to 7651. Knowing fully well we've substituted our formula, our first time was 7 and our common ratio is 3. So the sum of the first 7 terms of this geometric progression is equal to 7651. I would like you to solve questions so that to know how far we have gone in this GP, the sum of GP. Before I proceed, I want you to solve these few evaluations. Wow, I am so delighted that you got the answer correctly. If you still have a shady mind over this sum of GP, I would like you to rewind back so as to understand it accurately. Let us move forward by knowing another steps in these geometric progressions, which is called geometric mean. Geometric mean. Geometric mean has a formula that we have to know, and the formula of the geometric mean, Gm, is equal to root of first time L. That is, this is our first time and this is our last time. That's the meaning of geometric mean. That is root of AL. Root of AL, where A is equal to first term, where A is equal to first term, A equal to first term, L equal to last term. Just root, that will give us geometric mean. Geometric mean. That's the formula. Let's take, for example, find the geometric mean of 3 and 48. Find the geometric mean of 3 and 48. Example on geometric mean. Find the geometric mean of 3 and 48. I'd like you to be very, very inquisitive. Whenever they ask a question, root AL is our geometric mean. Don't be confused about this. The first term that will first appear in number is the first term, while the last term is the one that will follow. Therefore, our GM solution is equal to root AL. Our A is equal to 3. Our last term equal to 48. We now have GM is equal to root. First time is 3 times 48. We have GM is equal to 3 times 48 will give us 144. 3 times 48 will give us 144. What is the root of 144? The root of 144 is equal to 12. So our geometric mean in this question is 12. That is the geometric mean. Now, I would like us to solve few evaluations about these questions so as to know how far we understood geometric mean, geometric progressions, sum of geometric progressions, the end time of geometric progressions. These formulas are different. Remember, I told you the formula for the sum of geometric progressions, which is equal to A bracket into R raised to power n minus 1 over R minus 1, in which the common ratio is greater than 1. Now, the end time of a geometric progression is equal to Tn equal to A R raised to power n minus 1. Knowing fully well our A is the first term, our n is the end term. Please don't be confused about sum of geometric mean and the end time. They are different. And the sum of geometric mean. Now, solve these few evaluations so as to know the way we understood geometric progressions in terms of their geometric mean. Thank you. Thank you. I'm so much delighted because you understood all the explanation I've been giving you earlier on. Let us forge ahead by knowing another terminology which is called sum of infinite series. What is the meaning of infinite? Infinite means something that is uncountable. A number can appear in terms of geometric progressions which can be infinite. How do we solve those kind of questions? Is what we're supposed to be asking ourselves. And how do we solve it? There are formula for finding the sum of infinite series. 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 There are formula by which we can use for sum of infinite series, and the formula is equal to S. X is denoted by A over R minus 1. A over R minus 1. A over R minus 1. If in this aspect R is greater than 1, we still have sum of infinite series in GP, which is equal to A over 1 minus R. If is a conditional statement, as I've said, R is greater than 1, we use R minus 1. If R is less than 1, that is, R is less than 1, we use 1 minus R. So this is the sum of infinite series that we can use. Our A is the first time that we all know. Our R is the what? Is the common ratio. With this, I know you have understood geometric progressions, and I know that you will not have any biased mind in solving the questions under geometric progressions. Thank you.